तीर्थ सारंग करो ये।
Hello. Do you hear me?
Yes sir, yes sir. Good afternoon sir. Just 1 minute, we are doing you as a host. Good afternoon, good evening to everyone. My voice is audible to all. Please join as your resource person already joined. Quickly, within 5 minutes, we will start our session. Good evening to all. Let us start our online Atal FDP Day 3 program. In session 5, we have our most eminent person, Chittaranjan Pradhan sir, Dr. Chittaranjan Pradhan. He has received PhD alumni from Indian Institute of Technology, Bhubaneswar, India in 2018. He was a postdoctoral fellow with the Acting Center for Sustainable Energy, Faculty of Science and Technology, UIT, the Arctic University of Norway, Tromsø, Norway in 2020. He is currently a senior R&D e-mobility engineer with Volvo Construction Equipments, Eskilstuna, Sweden. His research interest is focused on the areas of power electronics control, smart grids, electric vehicle, and clean energy technologies. He is reviewer member of various international journal and conference, including IEEE, IET, MDPI, Willie, Taylor, and Francis, and Elsevier, etc. Sir, we are thankful that we have received our as a research person, you have received this, and I welcome you. Please start your session. Thank you, sir. You can carry on, sir. Sir, am I audible to you?
Yeah. Do you see my screen?
Yes. Yes, sir. Yes, sir. You will see your screen. Your voice is clearly audible. Now you can carry on your slide.
First, okay. First, thank you to all the participants and Priya sir, and also to the faculty development team for giving me the opportunity to present today's section. So normally the theme of this program is based on drone technology, but I'm working on the e-mobility and the power electronics domain. So I have taken some of the slides how this drone technology will be helpful for the e-mobility and the power electronics, and of course for the challenges and opportunities in case of e-mobility, power electronics, and of course in the drone systems. So the presentation mostly I focus both on research related, also in the industrial domain if someone is going to be showing his or her interest. So the outline of today's presentation, first I'll start from the evolution of vehicle technology or vehicle architecture, then drone technology, how can we add value to the e-mobility future. Then I have some example, the Volvo systems, which is called the traction voltage system. One example, you can take one of the part or component charging unit system. Then power electronics and what is the technical and commercial solutions for the challenges and issues we have. So now come to the evolution of your electrical vehicle. Then my first question will come to all of us, that is why the electrical vehicle now we're talking about. So because this answer mostly of us. The first thing, the sustainability. You need a greener energy, greener surrounding, simple, higher efficiency, because the availability of the conventional fuels is the limitation of the availability, price. So by seeing all the scenarios, so we are trying to focus towards the more sustainability.
Excuse me, sir. Please play this slide.
Yeah.
Okay. Thank you, sir.
Is it okay now?
Yes, sir. Yes, sir.
So the already what the part already we have discussed. So global warming or harmful emissions, noise pollutions, health benefits, optimum way to utilize the resources. So lots of advantages we are talking about, but also there's a lots of challenges: the weight, the size, the efficiency. But of course, there is a lots of challenges when talk about this e-mobility journey, because if you like a future goal, like especially this e-mobility or sustainability, mostly talk about the 2008 onwards. due to the evolution of the battery technology. And of course, now the fuel cell is additional energy storage is going to accelerate this journey. But before that, due to the battery technology, we are not to, because like if you go for back 80s also, some of the OEMs, they come to the market with their e-vehicles, but due to the battery technology, energy storage point of view, that was not fulfilled. But after 2008, this new era, you can talk about the battery technology, then that can accelerate to our green energy like your solar power or wind power. So that is all technology can correlate with the battery, what we can talk about. Now, if you see this journey, that is due to the, of course, the awareness of the people also, and also the government or incentives or policymakers, that also they are adding more value on this journey. So day by day or year by year, the demand for e-vehicles are going to higher. Now come to here, that is what we already discussed, the battery technology, because initially we had a small battery like 12 volt or 20 volt system only for your monitoring system, your wiper, and some few control point of view are using this battery. But later now we are going for fully lit battery vehicle system or fuel cell based systems that we can cover some hundreds of kilometers. So, but the main challenges, of course, when you talk about that is the thing is the range. When you go for the EV, mostly the range is one parameter, then the charging infrastructure and the cost. Because nowadays also mostly if you go for a full electrical vehicle or car, mostly 70 to 80% of price is coming from the battery. Then how this battery price will be going to reduce? But if you think in parallel, that is, we all are from the Indian society. Of course, as a world level, but Indian, the thinking, our belief is different. When you go for a electrical vehicle or any vehicle, that is connected with our status. So that is a additional value we can talk about if you compare with the other part of the world. So that is when that is the EV I'm going to own or any vehicle I'm going to own. Can I get the values like the design and the architecture, because always our nature is to show to others what I have owned. So that is the vehicle I own, that is how it looks. If you have a good value like good battery coverage, good range, less price, but if look is not good, then people don't own it. So that is an of course the value, that is the design, how it looks, or the architecture, the customer experience, because how we feel while driving. We get the experience like conventional vehicle or a new vehicle like EV vehicle, and also the status, of course, what I mentioned. We can also, that is another parameter, the cost and affordable, and the durability and the reliability, that is how long I can use, so or maintenance and performances. So while driving, so lots of things like the charging infrastructure or how to charge it or fuel economy. So all these things coming to the picture when you own a vehicle. Then each and every like the all this value chain should be smoothly run. Then someone going showing the interest to own the EV vehicle. So like the design and architecture might be some CAD, some mechanical work people can join. But when you talk about the more EV, that is how the experience, like more like we talk about the autonomous system, more user friendly, the data driven. Then at that time, the electronics engineering teams will become to the work. That is the communication, the charging infrastructure, like you can talk about how the smart billing. So that electrical, the charging infrastructure is coming to the electrical domain. But in case of this communication related, the cyber security, so lots of things that the electronics domain will come to their hand, how they will add value on their side. On the mechanical side, that is what is the structure you are using, that also they can value in the case of chemical engineering. So this is the collaboration work for each and every domain. Also the government, the policymakers. Now the next thing is coming, that is the EV, what we have won now or we are talking about, especially if you talk about Indian scenarios. And if you compare with the Nordic, where I'm right now in Sweden, so most of like 80 to 90% of the grid is powered by the renewable energy, mostly the hydropower. But if compare with Indian scenario, more than 70-80% of more also the energy coming from the conventional coal fire. So if you use your EV and you can talk about we are moving to a sustainability, then it is not fully we are agree with this. So for that we should do locally, like you can use your rooftop solar system or localized energy storage, or you can go for more of renewable energy dependent, more smart grid. Then if you have your electrical vehicle and other loads, how optimum we can use all these resources when the energy storage will work, when you can rely on the grid, because when the peak demand, the price will be also high if you pay for the electrical bills. So a complex algorithm also is required for the like electronics, because this workshop or this today's program mostly the electronics side, so I try to focus the electronics engineers how they can add more value. Okay, so that is the electronics side. Also, they have some role on that areas. The software side, the controller, the algorithm side. Also, the when go for this renewable energy integrated with the power factor, the additional the and also the grid synchronization. There is a lots of problem will become to happen, the technical issues and other issues. Then overloading, then how to the managing this power balancing between the grid and with your energy storages. All the value chains should be smooth, and how what is the incentives you are getting from the government, that is if you connect with the grid with your solar system or your batteries. And can your most of the vehicles what we are using right now, it is mostly charging purpose. Also, the batteries or the electrical vehicle can give the power to the grid when it's connected with the grid system, but it is not working or it's not on moving condition. So that way, bi-directional power flow. So the cyber security, if you go for more smart way, more autonomous systems, then the chances of cyber security, another problem will be there. So that's the thing should be take care. Then how the grid functionality as overall. Now some questions also come to like when you own a EV or any system, also correlated with a drone system also, because when you go for a drone, take the example, of course, in the latest slides, you can go for more detail. Now, if you own a electrical vehicle, then of course, as we discussed, the battery is the higher price if you own a EV. That is a for your application, if you go for a higher battery size or a lower battery capacity, which will be best for your use. Then what is the charging infrastructure you are seeing? You have different type like North America or China or Europe or India. All have countries have the different charging station. And also if you talk about Tesla, they have their own charging standard. So can we charge your vehicle for each and every charging station? And there should be a proper standardization and regulation, and the code compatibility should be there. Can you go for the battery swappable? If you talk about small vehicles, you can go for battery swapping. If you go for a vehicle, big car, or some other vehicles, can you go for that concept? Or can you charge your vehicle while driving? Take the example, your train system, your traction system. Okay. So while in the trains, normally we have the overhead lines, and some countries they are using the underhead lines while moving their powering to the vehicles. The same way, can you go for this concept for the electrical vehicles? So already this concept, some of the countries they have already implemented. While driving, you can charge your electrical vehicles with using a lesser capacity of the battery. You can save this money. And so another thing, the regenerative braking, that is while you are braking or downhilling, can you release the traction system power to the battery? Then that way you can save the energy and optimum way utilize the electrical vehicles. Then next day, what will be the technological side? You can talk about what will be the best, like your wire charger or conductive charger or wireless charger. So that is the different technical questions you should be come up, and we can add more value and work on this domain. Then the cost, capacity, then what is the domain you are working, then can you reduce the cost? Because always finally people talk about the performances with the cost. If the cost will be high, then sometimes people may not move that well, and it is safe because lots of safety regulations. So because you might be heard lots of news that the Tesla, some cars are going to fire by driving or where they're charging. So that the safe is another factor. Then if you that, because take the example like the battery, because what if you don't know what is the status of the battery life or what is the chemicals inside, then that way if you use it, then that might be fire. So can using the technology, any of the like AI or machine learning, anything, can you know the status of the battery life, the chemicals, what is used, or any parts? Then before that, you can take inspection or proper action so that we can safety and use it efficiently. So maybe the software side, machine learning, the electronics engineering, other domain, they can add more value. The material you are going to use also. So the safe or what so like the grid of what we talk about, the grid where we're going to charge your vehicles is in principle. Uh, then also like some background noise is coming, can mute it, please. So then the different actually the time slot like the charging normally in India also always they prefer to charge in the early morning or the internet light, because that way the grid you want to be overstressed, and also the charging the pay money you are going to pay that will be less. So that is the economic charging time. What is the time slot for you? So different things that is you should be aligning properly. Then you can get the answer and work on this specific domain. Then what are the requirements? Like if I to talk about like the longer life battery, the cell, the components what we're using, it is more recyclable, more sustainability, and you can think about push of the technology, new development, the packaging also, because mechanical side before, because what to talk discussion, the architecture and the design, because the same way a battery or any system should be look wise, performances wise, environmental wise should be properly packed, because the cooling, you might know the cooling each and every component is very temperature sensitive. So if you not properly material have chosen, the lifetime or the life cycle of the component or the system will be going to affected. Then the cyber security, what we have already talked now, the same way can you go for your scalability of the production of process, more modular way, and the reusability and innovation in technology. So this is because what we talk about based on your requirement, power level or energy level, then you can go for a modular solution and you can add accordingly. Then that way it will be more cost effective and you can come to the market with very faster. Then the auto billing or invoice or a human machine interface, that is you can while driving you can know your speed, your battery state of the charge, and the same way other status can you know, like you have a proper human machine interface systems. Now come to what is the now, because we have talked different challenges, different issues, then on which domain we can work and we can add more value. So, but the main barrier you can see that is the market, because the market sometimes the market is not ready due to the awareness and knowledge of the people, and of course there is the technology. Technically, the system is not so mature, so people are afraid to use it. Then also the policymakers, because the government or all the world leaders, if they will provide good policy and incentives to the people to use and promote the technology, then that will be go ahead. Then the infrastructure also same time so available, then so that you can use and maximum you can utilize that technology. So of course now, because what is the talk about the batteries or anything, the trade war is going on between US or China or throughout the world, like the rare earth material, you might know about the news, because the most of this maybe drone system or e-mobility system we are using the rare earth material. So instead of the rare earth materials, can you go for some alternative materials? And also you might know about different labor exploitation, especially in India or other part of the world, when we are going to extracting these materials or we are going to manufacturing. So these are the different challenges, but of course the key areas you can work on, like the energy storages, the battery, the fuel cell, or might be go for the supercapacitor. The power electronics domain, you can go for the wideband power electronics components like SiC or GN based, and also the packaging, because the module when going to packaging the ICs, that is the part of the electronics design, electronics engineer team, how they're going for pack this semiconductors materials, and how to improve their performances by reducing the parasitic elements. So that is the design side also they should work on. Then in case of electrical machine technology, okay, so what is the electrical motors are using, then you can go for some radial flux to axial flux, different techniques, there different types of rotor and starter technique or design or assembling things. Then the digital or AI era like machine learning, sensors, vehicle to grid or vehicle to X, anything. So vehicle to your mobile. So that way you can communicate and we can add more value for this journey. Then of course the standardization and the policy. If you see this is the cake of the whole e-mobility key technical areas, like take the example is the battery technology and charging, one of the part. Then packaging and cooling, wiring harness, this is another part of people can add more value. Then energy ecosystem, what to talk about the grid, sustainability, everything. Then control, safety and protection. So because safety is very, very important when you own any of the system or devices. Then another parameter, the software side, the connectivity and the security, the what already talk about the electronics domain. Then electrical machine, they also their own value and their contribution to this journey. Then the next one, the power electronics. So this is all areas we can think about, especially the battery point of view. If because the battery materials are very, very competitive. What we talk about the rare earth material and how the world is going this trade war. Because the battery mostly requires 6 times more critical minerals than the conventional cars. So we should think about it before adopting any technology, and we should think about the alternatives. So the same thing, that is how this automotive contribution to the electromobility journey. Because what your conventional automotive and where you are moving like your e-mobility, the same part if you go through like a regulation, technical, business and design. So as a electronics, like your infotainment, what we talk about starting, that is the design and architecture, that is infotainment, that you feel that pleasure while driving when you own a vehicle. Then interior, of course, if you, I don't know if you go through the Tesla, someone they don't like because the interior is nothing, but some other vehicles, the interior is so beautiful, then you can enjoy once you enter. So that is interior also there, the electrical powertrain, software. Then here, all these domains you should be take care and environmentally friendly. So that is some of the points of this is the contribution towards the e-mobility for in the future domain. The battery life cycles. Now come to our next slide, the drone technology, the contribution to the electromobility. Because already you know what is the drone system. So because this drone is a unmanned aerial vehicle or autonomous aircraft designed to operate remotely without a pilot. So this is the advantage, that is if you remotely operate any of the system which are called drone system, that is the communication is very, very important parameter. We have the sensors, we have the cameras, we have the control systems, we have motor also. So how this components, this technology should be go for in forefront and add more value. Because of course always you know what is the technology you are using, it is should be the technology should be differentiate for the existing one, then that will really add more value. Then you can think in the new technology, new research and in new area to work. So if you go for like a use cases where like a, because you know recently our India Pakistan the war, okay, or other countries like Israel or Hamas or other cases you might be know about the defense. Because The drone has taken a important role in case of defense, the disaster management, if people cannot reach there. And also you can the agriculture also to know the status of the soil, the weather prediction, delivery service, photography. So also nowadays also people are working on the urban movement also, like the normal car also. So these are different use cases nowadays we have in case of drone technology. Now, because I started presentation with the case of e-mobility or EV vehicle, then how this drone technology will going to add value in case of e-mobility journey. Because the plus point in case of drone technology, that is it is monitoring, because if you have enhancing the monitoring safety and efficiency of any system, then that the value what we can see in case of drone system or in case of e-mobility. Like we have different parts like low voltage, or we have sensors, so we have cameras, or we have a motor, we have an inverter, we have a charger system, and we have different cooling systems. So lots of we have a structural systems. So all this is systems what we have used in case of drone system or e-mobility system. You should start to inspect, or you can know how can you know the status, the life of the component. If they are working in properly, if there is wear and tear, if there is corrosion, or if there is a loose connection, because all the electrical connections are inside a vehicle, or how can we? So by the drone technology with proper cameras and sensors, we can identify with the data-driven and AI and machine learning. And the cracks, misalignment, the life of this is like the power electronics components, if there is a capacitor breakdown or bus bar breakdown, so we can detect and take the action before ahead of the time with the full failure of the components. So in this side, actually, what happened, like if Hyundai and some of the other competitors, they are using the AI system to for videography. Later already there's a charging system, all the existing EV system. Then if you are own a EV system, there's a integrated the charging for the drone. You can easily get with the vehicle. Then where you are traveling, we can before traveling we can know the weather condition. We can check the track and the route where you're traveling. So through the drone system, because in the recent some of the OEMs like Hyundai and BYD, they have a integrated charging facility for the drone system. Now talking about the charging infrastructure, where you start our discussions, because you know that is in Indian scenario, that is the charging infrastructure is not available each and every part of the corner of the country. So nowadays also some of the OEMs they are working on, can this drone system can charge to the electrical vehicles. Let's take the example. We have a drone station here. All these drone stations are here. They have charged with the solar or with renewable energy. If you are stock your vehicle is here or somewhere here, then what will happen if you want to charge? Conventionally, should come to the charging station. But if you are in the middle of the road, if you want to charge, then we can communicate through different apps for the drone station. Then the drone will come with an integrated battery. Then you can charge your vehicle at any of the time or anywhere. So that way you can save time. Instead if you go to the charging station, you should follow this path. But if you are here, the drone can travel through the air, then with less resources and the cost, we can charge your vehicle at any time. So, but of course, so when talking about these drone systems, like what will be the future, like the technology, what are you using? You should have a proper digital twin or simulation for decision making, for the span life cycle and how it behaves in the throughout the use period. The real-time data link to the EV control system, for instance, the alert. Not for in the EV, for other applications also we can use the drone systems. Then the quality, especially quality control, the logistic also we can use through the drone system. That will be add more value. But of course, the AI and machine learning, without this, or the autonomous system or the whole pilot system cannot be fulfilled. So you should be thinking about that is how this technology can add more value to the drone system so that you can use in different domains, not in the e-mobility domain, for like logistics, for the defense and other domains also. But of course, there will always be a competitiveness of when you work on this technology, that is the cost. Always the people who, what will be the cost of the product or how. Then the speed to the market. You should be always work with it, how to come to the market very faster. Okay, faster have the priority, then you get the better what in case of market responsibility, and we will be the leader. Then technology differentiation, competitiveness, and innovation, because that is a very, very important parameter. What the technology you have and how it will be differentiated from other competitors, and with your work and your research and development. The safety and protection, this is very, very, without this, any technology cannot be fulfilled. And of course, finally, the performances and quality for which purpose that system is going to build or manufacture or developed. So now we are go for the vehicle. We have talked different parts. Okay, but now go for how this is EV domain, in case of power, in case of energy, in case of autonomous, how this journey really starts. If you go for this background, the architecture, in case of electrical or electronics point of view, like if in 1950s or 2000 or now around 2020, that is initially we have a very small battery which is used for some signal or some only very controller point of view, some valve or something. But if you go for 2010, then we have the voltage only here 12 volt in 90s, but here if you see both high voltage and low voltage, the number of wires, harnesses and connection is going to high. But if now we are here in 2020 or 2025, in case of voltage, high voltage, now mostly the batteries you are using a 48 volt or maybe 200 volt, 400, 600 for Volvo using, and other OEMs, some of they are using 1000, the high voltage DC system they are using. But in case of the signaling and monitoring, they mostly use for 12 volt and 20 volt. But the number of OERs, the autonomous, the sensors, the cyber security, that part, if you see, it is going increasing day by day. So if when you talk about more autonomous system or more like if when the drone system, it is because pilot you can controlling, then the signal or sensors part will be going to increasing. It will be applied for each and every domain if you are going for more autonomous system. Of course, there are some challenges on that. So from now here, in case of Volvo point of view or other OEMs, one of the part is called the electrical distribution system, EDS system. Normally, the EDS system is the combination of both the harness with the high voltage system. In high voltage system, we may talk about 400 or 600, mostly vehicle OEMs they are using, and the low voltage for the signal they are using for 12 volt or 20 volt system. So it is the components which including the wires, cables, all the junction box, fuses, connectors. So what is called the EDS system, if you heard some people those who are working on the e-mobility domain, they might be using this word EDS point. So this is both high voltage and the low voltage systems. Then the fun fact about the EDS system, if you tear down any vehicle recently, that is a more than like a vehicle contains more than 70 special type of cables, data centers, USB cables, sensors, so and over more than 3000 OERs. And if you take approximately, it is vehicle to vehicle, that will vary 62 and or 100 kg or more. Okay, if you go for more autonomous system, then that will be might be changes. Okay. Now this is the some of the vehicles what we are working in our electric journey. Like you have a hauler, we have a wheel loader. This is called a excavator. You might have heard about the JCB in India. So also you are working the similar type of vehicles at Volvo, and this is a energy storage. So like mostly these vehicles, the constructions was sites mostly away from the city. So for that, sometimes you may not find a proper charging infrastructure. So for that, we have a portable charging station. We have a integrated battery. We can charge the battery on any of the charging station. Then after that, you can carry this unit to the site where these construction machines are there. Then you can charge on the site. And here another term might be in case of this EV domain people, they use mostly the traction voltage system or high voltage system. So this is called mostly the high voltage system, what we talk about 400 or 600 voltage. So they have classified the different voltage range, that is class A, class B, or class C. So normally most of the electrical vehicles, mostly the fully battery electrical vehicles, they are working on this class B, that is a 60 volt to 1500 the DC. This is the range most of the OEMs they are working on this domain. But in case of, if we talk about the Volvo, we have different variant of machines based on their battery, based on their motor capacity. So one is called your compact machine. It is work with 40 volt, but in case of medium, large and heavy machines, mostly they are work approximately 600 voltage recently. And based on their power level, what is the capacity of our powertrain system, we have distinguished that is the medium platform or this is a large platform vehicles. So when you talk about this traction voltage system, so there are different components. If you talk about your onboard charger, we have a inverter, we have motor, we have the battery pack. So all are coming belongs to these parts. And so this is the one of the structure architecture. So like take the example electric vehicle. So this is a common big box, because if you talk about any vehicle, because the look wise and safety, it is very priority. So what is the cables or harness we are using, you cannot just route it randomly, because we have some industry regulations and standards. So for that, the connection should be followed as per the industrial regulations. So for that, let you have take the example here, you have a DC, and here other components like you have the battery here, battery pack. So you cannot just connect the cables. So for that, if you use a long cable, what will happen or harness, there will be a EMI issues, then routing issues, then other safety issues will become. So for that, we have a big junction box, which is a smart junction box, which is called power distribution unity. So this power distribution unity is works as a junction box. So they have a smartless like the temperature, over voltage, over current sensors, and other protection safety systems are there. Then they are connected with the specific connectors are there, both inlet side and outlet side. So this is the normal architecture for the traction voltage system. Mostly all OEMs following based on their own name and trade names. Like here we can talk about PDU. So some OEMs are using the same junction box with a smartness features with another name. So now this is one of the architecture we are talking about to the vehicle architecture for electrical and electronics point of view. So what we have shown here, it is mostly the high voltage point of view. What is the components like we have a battery pack, we have the motor, and we have the onboard charger, and this is a CSU, is a charging control unit. This is another smart junction box. We have a DC, we have a, this is your thermal control cooling. This is all because of when you see a vehicle, we need a cooling system. Also, we need the thermal management, the temperature controller. So this is, we have different components as a whole. Then you can see a whole electrical vehicles. And if you see this, then this is the how already you talk about nearly 70-80 kgs of you see this wearing harness the weight, but it is based on the vehicle. So it might be more sometimes based on the vehicle how it is. Then here one of the examples that is of a electrical vehicle or hauler system. We have using a 2 electrical motors. It is nearly 200 kilowatt each motor we have, and we have 5 to 6 batteries we have using these specific machines, and each battery pack it is a 90 kilowatt hour. Then you just multiply with 5 and 6, then can know what is the total capacity. Then PGV is a power junction box. Then we have a compressor, we have a coolant pump, we have electric fan, you have heater and the chiller. Then we have some smart controller for this controlling everything. So this is called as a brain of our e-mobility system, and the DQ also, because in a construction vehicle they have their different functions to shifting the load here and there, up and down. So this is another controller we can talk about, and this is a CCC is a thermal management controller. So here you have a onboard charger, you need charge. So all are the whole, then this is different parts for e-mobility system. Now we talk about the another part also, the electrical propulsion system. So the electrical propulsion system, mostly it is connected to the battery that is convert electrical energy to mechanical energy and vice versa. Mostly our powertrain systems are connected with the battery as a whole. So when you talk about this EPS system, because as a electrical, there's lots of safety regulation that is should be fulfilled. So if you see any vehicle, we have different safety parameters or safety precautions or devices you have used. One is HVIL, hazardous voltage interlock loop. Another is the IRM, insulation resistance, because always because all these high voltage systems are some insulation is there, or when the short circuit and maybe tossed with some other conductive material. So if the insulation will be damaged, always it will be problem for the end user, maybe life or the vehicle or the system. So always you try to always measuring the insulation resistance. If it is some mega ohm, then it's okay. If it's something the insulation is damaged or tear, then you can easily measure. So always you have a smart measuring system is used, which is called TVMU. So in case of Volvo or other OEMs also, they are always monitoring this insulation level of the cables or connectors. And also with the high voltage interlock, so we can go through the next slide. So the high voltage interlock, that is, this is a, like you know, that is you have different systems like the battery, we have a motor, we have other components like motor or DC-DC. If in any cases any of the high voltage component, the connector is going to lose, then if he suddenly, if he may anyway or servicing time, if he someone maybe come in touch, then that will be short circuit. Unintentionally, maybe someone going to open, then what will happen? If you take the example, these are connected. If you open this path in unintentionally, then this closed path will going to break. Okay. So if this closed path will be break, then automatically, I told there is a main brain. The control will be there, then can sense the high voltage connector is going to open that specific part or somewhere. Then if your relays and contactor will automatically going to open to save the person and save the vehicle. So this is the some of the controller techniques they are using in these vehicles for the safe and protection point of view. So this is the same way, like if you see any connector, a high voltage connector, there's a two small pins. It is like a series connected path actually for each and every high voltage components. So if we like if a series connected OR, if any of the path will break, then whole path will be break. Then easily you can identify. We are using this device which is called TVMU, who can sense that break or that give your protection to the whole vehicle system. So for that, actually, we have different algorithm. We are using different criteria. If this resistance value or leakage current value going from beyond some values, then automatically that controller is going to picture and save to the vehicle. Then already we discussed the isolation monitoring or insulation resistance monitoring. Also, that is another parameter if any of the insulation of the cable or harness is going to damper or affected. That way also you can get the HMI or get the signals. Then after that you can take proper action to save. Then here I have taken one example of a unity, CSU, charging control unity. Already I already told this talk. So how this I have taken in this example, but you can correlate what is the learning you have taken from this unity. You can apply for electrical motors and other like DC-DC or inverter or any of the components. Okay, on electrical like the controller unit, mostly the electronics engineering point of view. That application is for each and every domain or each and every components and every industry also. So if you see here, like the charging system we are talking about, mostly you are charged through your AC plug or maybe DC. DC normally you talk about the fast charging. So when you charge your vehicle with the fast charging, then that is the power. It is normally very high power. Normally at Volvo we are working with the maximum 250 recently, but we are planning for 350 kilowatt, the DC power. So when you go with high power charging, then what will happen? This is the CSU, like this is the fast charger. Then because it is when high current will flow through the system to the battery, then what the system will going to overheat it because I square are there the resistance. So that is always you should know that is your system is not going to overheat it. And also it is not be if some issues might be over voltage or over current, then how can you protect your system while charging with high power? So this CSU acting as a gateway between your charging here VSC, what we call the charging side, and this is your EPS system, what we already discussed. Our all the high voltage system is called your EPS systems. This is acts as a gateway. So here in this case, we are different variants of EPS. So one is your DC charger, another is like onboard charger you are using, another is a fast charger. We can connect it both of these two units because output of your onboard charger like a AC to DC charger also it is DC, the output of onboard charger. So all these two cables with fast charger and output both are connected these two units. This is called 2 EPS. So someone also we have only one EPS. It is connected only the fast charger. There is no slow charger or AC charger is there. So this is the some electrical architecture you can see here. That is we have this is your input side. This is another output side. So and there is a smart controller through which you can measure the voltage, sense the current and the everything. And we have a contactor. So based on if you find is there any deviation, then you can save your whole vehicle and open the contactor if any abnormality is going to happen. So everything will be happen through the CAN communication. So already electronics engineer this controller things is needed for the electronics engineer. They will work on the software side and the CAN communication sides. So mostly are using the vector CAN communication, and also Volvo have its own standard, and each OEMs they are following some regulation in this CAN communication things. So that is they have their important role in case of this. And already I told that we have a brain, the SPCU. So this high power control unit, it will be always take the final decision. But this is the initial sensor. Everything will be taken the decision by the specific this unity. So this is the if you see, this is the internal structure with the bus bar, the contactors. We have all these signals, and what to talk about the HDIL, all these high voltage signals are there. And if you see, this is the low voltage connector because of what is this points we have discussed. This is a high voltage side like 600 at our system, but this is the low voltage connected system for this CAN communication. We have the the different grounding and powering this low voltage signals. We have different CAN communications are there. Then it can communicate with the other vehicle component parts. So this is the thing what to talk about the safety and protection, the CAN, because also there's a PCB also because the temperature PCB is there for the controlling because the sensors, everything. Now this is the part what normal the electronics engineer can see. I have taken one example, the CAN communications for throughout the electrical vehicles. This is what to talk the brain of the system, and we have a A construction machines, we have different operational, like is lifting or siding to the haulers, everything. So this is called the queue. So if you see, you have battery system, you have CSU, and these are all the different ones, and they are communicated with a different way of a standard of communication. So if lean is there, we have EPS system. So this is the different communications that mostly the electronics engine, they are working on this architecture side mostly. And all the components are communicated and talk with each other through different CAN communication or lane communication. It depends actually on also internet is also there. Now recently we have implemented internet communication also. So now come to here what we discussed, because any component like drone or anything, we are following different from a structural part, from environmental part, the user part, we have different standards and the regulations you follow. So take the example like in case of the environmental, like where the component or device or system going to use. So we have a different vibration, different humidity, different thermal environment, and also the material content or the chemical content of that specific part or system that should be identified if it has some environmental impact. So all the standards and regulations should be fulfilled. So the same thing not only for this system, the same like the if you see any companies, the logo of any component also there is standards regulations also. Okay, the air should be so smooth. So lots of things is going to implement in case of a real life in when going to design and manufacturing. So, so all the engineering should come together and put their contribution, the packaging, the thermaling, the cooling. Then you can see as a whole component fulfill its requirement with performances. So now next we can go for the power electronics side. The evolution and future trends of power electronics. Now, you know, like if you see conventional any of our speaker or something that is the size is very big, but nowadays with the same capacity speaker with high performance, the sizes is going to very less because of the revolution of the semiconductor materials, their packaging side, their modeling size. So this because modeling and packaging mostly the important role taken by the electronics engineering and also the semiconductor side, the technique how you operate this power electronics systems, it is the electrical and also electronics engineering can add more value. So if you see here like day by day the power density of the components what we have seen before and nowadays the same with the high the components with the power density or energy density level is going to high, which is the price also going to reduce also day by day. So that is the advantages with this new technology for GAN or SiC based power electronic systems, and also the efficiency due to the revolution and due to the work on that domain, the benchmarking, the packaging. So that you can see this power electronics trends right now. But of course, there's a lot of challenges and issues we can go through. But when you talk about like here, like you have a power device from the die level, power module level, this module mostly in case of the power electronics engine, the packaging, because of how module they say power semiconductor systems or the special the elements. Then as a system level, this is the PCB, how you design, how to integrated the PCB design and all the component locations. So that as a whole, it will be affect the performances, the functions, and the EMI, so different thing on the safety, protection, the size. So all as a whole, you can take care. Then you can as a whole system level or a vehicle level or as a drone you are talking about. Then that system will be work efficiently. So I'm not going through this slide, but we already know that is the why you are talking about the GAN or SiC base, because due to the higher temperature, because they have more very thermally sustainability and they have very electron more velocity is there, and also high voltage level, because the energy gap is very higher. But of course, these two technologies, what we're talking about, these are not yet fully mature. So for that for the technology, when going to mature, then we can adopt it. And also, because when you talk about this high frequency, because if you go for high frequency, if you compare with your conventional in silicon based system, that is the snubber circuit might be not challenged. But in case of if you go for this is SIC or GN based systems, your snubber circuit and other switching circuits should be updated, otherwise there is other parallel issues are going to face. So when you talk about technology, there should be think about each and every domain actually. So this is the sum of already already we discussed actually the high power density, high thermal sustainability, high frequency operation. But of course the challenge is that these are very costly right now, and these are not fully mature right now, especially the GAN, because it is not yet fully mature. But SIC is going to very mature if you compare with the GAN based systems. Now this is the power module. So what we're talking about, like the in case of drone system, also we have a motor and we have a inverter and we have a DC-DC. Then this the ICG and the PCBs are there. So these systems actually how can work efficiently. Like if you talk about like conventional, if you see here this, that is the components we are talking about individual, like a MOSFET or IGBT or thyristor. But nowadays you are getting as a whole package or module system with their own safety and own controllability functionality, gate driver. So if you go for this way, it will be more compact, more add more value with additional functionality, and the cost will be also reduced. So that is the very packaging side that will be add more value. So instead of going for your conventional individual components. Then what the, because you when you go for this technology, because when you go for the soldering or wiring or routing or harness, because it is better if you go for bondless technology, no solder joint, sintered joint, reduce the switching losses, how efficiently in case of the PMW technology we are going to use. So these are different challenges and different issues of all are working on this domain. And what will be the alternate for GAN or SIC based, also that side is coming to the role. Now what we discussed, that is in the individual power electronic side as a challenge. But now you know,
the voice is not
always
audible.
the companies or end user want a small device with all the features, with more user friendly and very convenient. So it's not, is it audible? Hello, is it audible?
Continue, sir. Yes, sir. Yes, sir. Continue.
Yeah. So this is.
Sir, your voice is not audible, sir.
Is it okay now?
Yes, sir. Yes, sir. Continue.
Okay. So now another technology also going on each and every domain, like the before you the power module with technology, you talk about individually, go for individually components as a module. For a like inverter bridge or DC-DC bridge, you can go for a modular solution, like with their own controller and with the safety fixtures with IC. Okay, so that is the same way, like this is the packaging and modularity, the electronics design, they can add more value. But in case of take any system, like I am using a motor, and if the motor and the inverter or their controller, okay, power DC what might be, if both are coming as two different units, if some supplier come with a solution, the motor and their controller like inverter is as a integrated solution, then what will happen that the common parts, because when you go for integrated solution, that is individually taking two different or more systems, then when you combine as a one, then you can share some of the common parts, their functions. then that is what will happen. It will be more compact and more cost effective. So that is what will happen. The weight and the efficiency will be reduced. Okay, sorry, efficiency is going to high. So this is the one of the technology what the future mostly you can find each and every domain. So take the example what in case of power electronic side where you started. This is the like a 6 instead of individually the module like in thyristor or MOSFET or IGBT. Then you have a module where all the 6 MOSFET or IGBTs are there. Now here there's all this with their safety features, here gate drivers are there. But what about the motor technology and other devices like DC-DC? So if you talk about, when you talk about our starting discussion, the CSO, the charging control unit, like a smart junction box, the charging control unit with DC-DC can be as a single unity, the same way the DC-DC with the onboard charger can as come as a single unity. So this is one of the trend of the integrated solution mostly people are looking for. So if you see here, like this is a separate DC-DC and OBC. So if this is the integrated solution where OBC, DC-DC plus PDU as a one they are going to come. So this is the some of the future trend mostly the technology are looking for. Here OBC with DC-DC. So OBC with DC-DC with both AC charger and wireless charger. So this is the some of the integrated solution because already this already implemented some of the vehicles and the OEMs and the suppliers they are working parallelly with the systems. Now here 5 integrated onboard charger plus DC-DC. Then already we discussed actually the share the power electronics components and share microcontroller tax education. Okay, because we have shared some parts of some of the functions. Because like DC-DC and onboard charger, we have nearly similar functionality. Okay, some of the functions similar. Then that way, what the reduce the size, the cost, the higher power density, eliminates of extra wiring harness, connectors, housing. But the problem is that when go for integrated solution, there are many challenges, especially when go for integrated solution with high power density with a small area. The main problem will come to the packaging. Then when the packaging is more constant, then the thermal issue will become to the or hotspot is the main challenge. So and also the magnetic saturation. Then how to solve it? Already we discussed. Okay, next slide I'll go here. Okay, this is the some of the examples of some of the OEMs. Actually, they are working with this combo pack onboard charger plus DC-DC. Okay, this is some of the example I have given here. How this combo and those who are the companies or OEMs they are working with this combo like onboard charger plus DC-DC with motor plus inverter. But there are the different challenges. Here we can discuss this slide. Like both hardware challenge and software challenge. Like take the example, if you talk about onboard charger here, individually onboard charger, that is it is designed or the for specific application or the transformer or inductor you have used and the control algorithm you have used. But when both onboard charger and DC-DC both are combo pack, that is the software complexity will be higher. Because also the magnet you are using for specific application that might be saturation. Then the thermal hotspot will be the synchronization on multiple stages. That is when it will work as an onboard charger, when it will work as a DC-DC. So lots of synchronization and complex algorithms should be needed. Then the packaging, what we talk about, that is going to more thermal effect. Then the risks of overloading because the same parts are told because we have been getting the advantages of sharing the common parts, but some parts those are sharing this common functionality or operation that might be overstressed. That is overloading option will be there. So also like the non-linear load demand, like if onboard charger or DC-DC is designed for specific linear way, then you can track the performances everything. But when both are going to merge the functionality, that might be more non-linear in nature sometimes. So that way very difficult to predict the performances. Okay, so that way you should be take care, especially the controller algorithm, the software side, and the packaging. So these are the different challenges, and controller part and protection also another challenge. Okay, so you should be take care of these things. So to fulfill what to talk about to means higher integration means higher power density. Higher power density means higher temperature. But the main it will reflect with the thermal in final and the failure of the component. So then the inclusion part, like we have different type of packaging we can take care, and you have different type of thermal techniques you also can take care. So in industry, that is when you adopt any component or any system, before that actually we follows different international EU or India also we have different regulatory standard we have followed. So for that we have different type of test, like we have a vibration test, we have a dust test, moisture, then temperature, air pollution, then scratch resistance, different type of chemical resistance also, flammability, the material what you using. So these are the different tests before you are choosing maybe integrated solution. Maybe you can go for individual solution, but finally each and every component should undergo different tests to fulfill different environmental scenarios. Then that way you can pass it. In case of drone system, if you go for the some of the natural calamities or different harsh scenario, then we should that component system should undergo different tests. Then after that it can fulfill. Otherwise you cannot use that specific applications. Then also what to talk about another is the EMI, EMC or electrical issues what we already discussed. So also electrical when going to fulfill, they have different tests also they are going to fulfill based on different standards, like a over voltage, reverse voltage test, then a momentum voltage drop, then how to increase or reduce the voltage, low voltage like 24, 12 volt, then how the system is going to operate. Because suddenly, like if your battery voltage level going to change, if your system is sustain its functionality or is going to malfunction, and within which range it is going to operate below that domain. Otherwise, it is not going to operate properly or malfunction. Then high voltage, if this is a low voltage test, this is a high voltage like insulation, what we talk is very, very important parameter. Short circuit test, open circuit test, then over voltage turn, then the protection HVIL, pre-circuits, all the sensors, connectors, all the breakers, okay, the hot and cold temperature with high voltage, high current. So different tests we have undergone, then you can know that component is going to pass or fail. So for that, you test engineers require is that they are this side, both mechanical side, electronic side, the software side, because there are lots of software when you do this test, the software, the CAN analyzer, analysis, evaluate. So all people are needed for this different type of test and validation. Then here you can talk about this EMC, because when you talk about the EMC, that is always we are focusing like talk about here. Previously, instead of going for individual components, you could go for a single IC with multiple functionality, which can replace with individually many components. So that is the integrated solution with multi-functionality. And instead of going for like it individual like conventional temperature sensor or different like a speed control, torque control, if you go for a like a torque with speed sensor, so why not you go for estimate with some control algorithm? Like you can sense the voltage and current easily, then after that you can write your coding or software, then that can estimate to the torque and some other parameter. So the same way in case of like sensors or image processing, anything. So that way you sense few parameters, then you can go for estimate instead of using too many sensors or LiDAR, what we talk about in case of drone. So this is the then this way you can improve the performances and also the cost and the lifetime of the system. So in the finally, what you want to achieve for this electronic system or any of the drone system, that is high power density, high energy density, high switching frequency. Because for you go for high power electronic systems, then that way you can the size of the elements like inductor, capacitor, static elements will going to size will be less. You go for high switching frequency, but high switching frequency more EMINC challenges. Then that time you can go for a very soft switching, power factor correction, more shielding and grounding. So PCB layout, because very important para role come to here. Okay, the selection of the components with a lower parasite elements. Then already what we discussed, the selection of microcontroller IC with multiple functionality instead of individually components. Use less number of electronics components, compact size and small size. So if you go for bigger size, then the routing, because the routing also affect to the parasitic inductance, mostly that will be another EMIMC, so because it behaves as an antenna. So this is the different. Now if you talk about EMIC, EMC also, there is industry, they are different. When you validate any component, they have undergone different tests based on the industrial regulation, conducted transient emission, conducted and radiated radio frequency emission, conducted transient susceptibility, impulse to high voltage, radiated susceptibility, so ball current injection. So different tests also, flickering and noising. So different tests are actually this component is going to fulfill before going to pass or use in the practical applications. So this is the mostly the what we already discussed, the electronics engineering side, how module this systems, your electronic systems or power electronic systems, from the packaging, component integration, how to integrate these components. So different techniques you can 3D power integration. So before going for this, you should go for a proper technique to select for based on your application, the cost and the performances. So this is based on the motor, also motor side. Also there is lots of work is going on how to, in case of the selection, their packaging, and the design and development point of view. Now we because we have already discussed more of the things about both EV, electrical vehicle, and the drone technology, and in case of power electronics. Then what is the technical and commercial solutions for that? Okay, because if you go through like overall, in case of drone, like a maximization of parts of inverter electrical machines. So what we call the integration. Okay, integration solution in case of drone system or any other application, can it is better to maximize of common parts, go for integration solution. But when go for integration solution, that is the challenges and issues we should be take care and should be add on more value. Then next generation, the power modules, the bondless, more efficient and scalable solution. Then the IGBT and MOSFET, what talk about the SiC and GN based. Then in case of the drone or any applications, the rare earth material we are talking about, we should think about what to be the alternative, which is not belongs to that rare earth. They know can sustain that technology for long period of time without affecting the resources. Then advanced or smart controllers and software, of course, you can go for other for efficient or more HMI related applications. Noise, vibration, harness, because that is very important parameter for the design and development. So what we're talking on about, then I can go to the, this is all this what already I focused actually. Now this is my last slide, because what we are talking about, this is the finally the technology, the tool we are using, the analysis, because in practically if you go for testing and validation and adoption, it will take lots of time and resources, the budget also. So for that, it is better to go for using a modeling or virtual or multi-physics simulation platform, or what to talk about the digital twin, okay, platform through which you can save lots of time and resources to analysis and adapt for the life cycle of the whole systems. And in case of the battery or any physical structure, you can easily analysis their performances with time, which is what we cannot do in practically, because you need a costly set of the test and performances. Okay, that way you can save the time and cost, and faster way you can come with new design and innovation. So, and also can analyze the future uncertainties and unpredictability scenarios, the complexity what is behind this. So you can easily take any scenario in case of you go for in this multi-physics and this digital twin platforms. But of course, if you go for let you talk about the cyber security is very important parameter when go for more autonomous system and more of smartness on your devices. So the data theft is very challenge. Not only for any device you're using, also in our own personal data what we use in mobile system also. So the collection data analysis, then we can go for more decision making for application of artificial intelligence, machine learning, the software what already discussed. For this, you need a software team who can work in specific areas and domains. Then here also use of advanced simulation tool, the finite element method, multi-physics, like sometimes what to talk about like the thermal analysis or structure, everything you can go for this multi-physics okay, analysis software to know their EMC, EMIMC analysis, electromagnetic performances, thermal analysis, vibration, everything we can go for this uncertainty analysis. Then of course, finally, you need a better service and maintenance people, skilled people. Then without the support from the government, we cannot move forward actually. So the government should be promote these technologies, new skills and new areas. Then finally, because what we discussed like the relay, because what is the system you are using, finally the durability, the lifetime, that is very important parameter. So of course, so we have the systems are undergone different type of test. Okay, the reliability analysis, durability test. Okay, because what is the test to discuss in case of a lifetime test, we have some harsh condition like a what is the vibration test. Take the example, which is some additional temperature like a 50 degree or 60 degree or 70-degree temperature you can undergo the test. Okay, instead of a normal like a 25-degree temperature. So these are some harsh scenario we can test. So another than failure mode and effect analysis, this is actually maybe all the engineers, not in electrical, electronics, mechanical, all engineers they needed based on their system. Actually, why this any component, any system going to fail or any of the part like electrical point of view or mechanical point of view. Then what is the main reason for the failure? Then what is the action going to take to improve? And then can you detect the failure mode analysis? So this is the some of the things what actually you are not studied in our universities. Okay, this failure mode and what I talk about the CAN communication, especially what is the you have designed like take the example I am designing inverter controller, but normally my lab I just to make the three-leg inverter, but after that I have get driver with controller. But in practically application, all this industry, especially e-mobility industry, you are communicate through this CAN communication. Actually, what to normally you don't know about this. It's true where before joining I didn't know about, but you should more idea about this CAN communication. Before that will be add more value to your career growth because there's a different challenges for electrical side, mechanical side, packaging side, every and of course battery part is lots of things are there also the same thing because if what we discuss the same also applicable for the battery as a whole. Okay, the safety, protection, performances, uh, integration solution, new alternate material, new packaging in case of the how the software complexity to be solved, how to test very effectively. So this is the new things you can choose any of the domain as per your interest add more value. So I think collaboration as a one team, then all will come together and add their skills and expertise and do their research and development. Then as a whole, you can see a system as a complete. Otherwise, the system won't be complete without the collaboration or teamwork. Do you have any questions? Hello, do you hear me? Okay.
Okay, sir. Thank you, sir, for your enlightening and inspiring speech. We truly appreciate your valuable time and insight you shared with us today. Thank you. Thank you so much, sir. Thank you, sir.
Yeah, yeah. Thank you once again, Priya sir, and to the team of for faculty development for your time and giving the opportunity to present some work here. I'm really glad for this, and also, of course, my thankful to the Iron Engineering College. Okay, thank you.
Thank you, sir.
Okay, you are welcome.
Thank you so much.
Thank you.
Thank you, sir. Okay, dear participants, our next session will start after 10 minutes. So all the participants are requested to join after 10 minutes for our next session. So let's meet after a short break. Thank you. Thank you all.
Hello, sir. Hello. Am I audible, sir? Abhimanyu, sir?
Yes, sir.
Okay. I just want to ensure before the participants come live, I just want to ensure that we are having all the settings ready. Yes, sir. Okay. We'll wait for them.
Okay, sir. Actually, we get them 10 minutes,
Yes, sir.
10 minutes break. So after 10 minutes, we will start.
Yes, sir. Yes, sir. Just I am checking my uh, webcam and all these things. So my
Yes,
audio,
sir. Yes, sir.
audio is okay,
Yes,
fine. And
yes, sir.
how
It is
about
okay.
the video, sir? Video is fine.
Yes, sir. It is also fine.
Okay. Okay. Thank you very much.
Please be sir, be there just in a 5 minutes or 10 minutes. We will start the session. Just a 5 minute break to all of you. At 3:35, sorry, 7:35, we can start. It's okay,
Good
okay, sir.
evening, sir. Sarpati, sir. Sarpati, sir.
Good
Good
evening,
evening.
sir. Good evening, sir. Sir,
Yes.
after 5
We'll
minutes,
start in 10 minutes.
yes, sir.
Yes,
Yes,
yes.
sir.
7:35, 7:35 we'll start.
Yes, yes. All of you be
Yes, sir.
present. Thank you.
Yes, sir. Yes, sir. Thank you.
So good evening to all. Let's come back to our session 6 of day 3 of our online FDP program. Due to some emergency, some of our resource persons are not available. So in a quick time, sir will join with us, Dr. BKC Ganesh sir, which will be completed their BTech or Bachelor Engineering from Amravati University, Maharashtra in 1996. He completed his Master from BITS Pilani, Autonomous 1998, PhD from Andhra University 2014. Recently in 2022, he had visited University of Basel, Switzerland for advanced training in automation and digital manufacturing. After working in teaching for very long duration, he founded his own company, Neotrend 3D Technology, in 2020 at Tirupati, Andhra Pradesh, which offers intensive workshops and training in 3D printing, robotics, and IoT programming for all branches of engineering. He provides training and internship in the area of 3D printing, IoT, and embedded system app development using ChatGPT and cloud computing. As a research person, we are incredibly fortunate to have someone like Sir, which will be a gentleman point of view. At any moment I call him, he agreed to, sir, I will agree to any time, any day. They will be he will be deliver any type of topic. Please
Thank you,
join
sir.
me in offering a very enthusiastic welcome to Dr. Vicky Ganesh sir. Please, sir, you continue for your whatever you want to then deliver. All the participants are eagerly waiting for us. Thank you, sir.
Yes,
Continue, sir.
Thank you, sir. Thank you very much. Good evening, friends. I first of all would like to thank the management of Aryan Aiet, Institute of Engineering and Technology management, as well as I would like to thank Satpati sir and Abhimanyu Kar sir, who are the coordinators and co-coordinators of this event. So it is nice to connect with you all over India. I am basically getting in touch with you from Pune, where I am also working as an adjunct professor in computer science department at Achankaya D.Y. Patil University, Pune. And I also have my own startup, that is Print 3D Technologies. Okay, so I am both an academician as well as an entrepreneur. And in earlier part of my life, I was also a scientist. I published good number of research papers. Now, most of the time, I dedicate myself to the integrating of these technologies. So our basic topic is integrating AI with drones. Okay, so what I am specialized at is that I am integrating not only the artificial intelligence, I am integrating the artificial intelligence and machine learning, IoT, cloud, and all these particular things. So I think I am the one of the best suited person to deliver this talk to you, and of course have some feedback from your side also. Okay, so having excited by the technology, emerging technology, I can say it's an emerging technology. So what I have done is that in 2020, I left my job in teaching, where I was working as a professor in one of the esteemed university in Andhra Pradesh. So I ventured into this field of IoT and cloud, AI, ML, and all these things. The main reason behind this was that I was mesmerized with the technology of this cut engine, where I saw in the YouTube cut engine of the, what I can tell you, the cut engine of the Tesla. I have seen cut engine of the Tesla, where the microprocessors, microcontrollers, and sensors, all these communicate with each other. Okay, And I had an opportunity to visit Switzerland in the year 2022 for my training in automation and digital manufacturing. It is in Basel, which is very near to the Zurich. And I had an opportunity to visit a number of universities at Switzerland where the approach is multidisciplinary. But in our India, we have curriculum-based education and branch segregated. Mechanical means you will only study mechanical, computer science only computer science, like this. So there is no integration of these things. There is high chance of probability that one might venture into the other branch and try to learn the things. So I would like to open the gates of these interdisciplinary domains or restrictions and work towards a common goal of developing projects. So why do we have to go interdisciplinary? So that is the most important discussion that I would like to have today. Because if you see the Tesla car, you have a battery pack. Battery pack is the most important constant of that. And then you have a microcontroller. You have an inverter to convert that AC charge into the DC. And then you have this DC motor. And all these things, when I had opportunity to see this Tesla car, European model, they drive on right, just like us. Most of the Europeans drive on right, whereas the left-hand driving is in the US. So I was first astonished to see in the bonnet there is no engine, and to see in the back also dashboard. Sorry, in the dashboard there is no engine, and the bonnet also there is no engine. The engine is just a motor, and there is a battery pack. See how beautifully things have been concised into this smallest thing. You see, in our olden days, in our childhood, the ECTV, Dianera, and all these particular things. Odisha also has got one TV which was very famous at that time. It is, I think, some ECTV or something. Very famous for that production of that TV. But now you see LCD screen is just very small and light and all these things. So world is going towards an interdisciplinary approach, the first point. Another one is going towards a compact size thing, less maintenance, more durability, and all these particular things. At the same circumstances, there is an integration of this AI, IoT, and cloud technologies in various aspects. There is an AI in the manufacturing, there is an AI in the automation, there is an AI in the drone technology. So AI is in every part of these things. So my dear friends, I would like to ask you, please open your chat box and type, why do we have AI in these fields? Why do we have to integrate AI in these fields? Can you please type? We have 2 minutes. I will just go through and then give my suggestions. Please type, why do we require AI in today's world? My dear friends, please type your message. Can you listen to me? Are you there? Please. Are you there? Are there any messages?
Yes, sir.
Yeah, can you type a message? Why do we require AI? Because I want this to be interactive. It's not that I just give to tell something and you just have to listen. Can you type, why do we require AI to be integrated in today's world? Anyone? Or somebody can unmute and tell, somebody can unmute and themselves and tell me. If they don't feel messaging is good, comfortable. Anyone can unmute and tell me, why do we require AI? Come on. In today's world. Yeah, somebody can unmute and tell me.
AI is summarized easily. AI is
Yeah.
summarized easily.
AI is what? Lakshmi,
Yes, sir.
what is AI?
Summarize.
What is
Yeah, is summarized easily, sir. You can.
AI is summarized easily. Okay. Any other?
Good evening, sir.
Any other? Please.
Actually, the requirement of AI because it has to, as it nowadays we need lots of data to process, and as we know, the all the data cannot be transmitted to the ground uh, in live. So it needs to be processed the large scale of data and the filter the data and send the accurate as the requirements
Yes.
and the
Yes.
process.
Good, my dear friends. Good, good, good. Satya. Good. Thank you very much. Yeah. To improve decision making, AI make
Yes.
things faster. Super. To handle big data. Oh, so many. Oh. Super. Wow, wow. Very beautiful, Sakshi Kala to improve decision making. Ritu Beniwal to process data quickly. AI make things faster to handle big data. It's beautiful, my dear friends. Thank you very much for your feedback. Okay, now I will go ahead. So, in my perspective, AI is meant because I've seen the autopilot system of a Tesla car, which is you don't have to drive it. You are completely burn out after working some 8 hours or 9 hours in office, and you just put the car in autopilot and just go to sleep. That's it. It beautifully drives you home, my dear friends. Today, Tesla has got an advanced feature that, my dear friends, you will be surprised to know. You book a car from the factory and it is going to be delivered to your home driverless, right? Okay, there are also Waymo cars in California, Colorado, and all these particular things which are driverless, where anyone can book a cab at 2 o'clock in the night and the car comes home driverless. Okay, so this is the advancement of AI. AI is meant to not only improve the luxury living style of the humanity. Okay, at the same circumstances, it is helpful in making mankind to concentrate on more important tasks other than the routine general course and all these particular things. So AI is coming in a big way, my dear friends. You cannot expect in the next 5 years. We have already seen the generative AI applications and all these particular things. So with that introduction, I just want to give one more case study. So why do we have, if we suppose put an AI in the AC machine, what will happen? If we put an AI in the AC machine, what will happen, my dear friends? Anyone? AI making problem solving and human learning? Yes, sir. Good. Good, sir. Arun Kumar, sir. If I am putting an AI into an AC machine, what is the impact? Can anyone tell me? Quick. We have less time. Somebody can unmute and tell me. Predictive maintenance. Okay.
Yes, sir.
Yeah.
Actually, we do not need any room temperature. We not interfere to the how to control up the AC temperature up down. We do not need to do that. It will manage itself, the temperature and the humidity also.
Super, sir. Super. Satya, sir, thank you very much. Yes. So, very beautifully you have said, sir. Because actually what we are trying to do, we are actually setting up AI saves time and useful in weather forecast. Super, sir. Super. So, what we are trying to do, we are having a thermostat, we are setting a temperature 24 degrees or something. And what is happening? Once it reaches 24, it will automatically, the compressor will cut down and maintain the temperature at 24. So what if we have an AI trained model into the AC, that if it's very chill, then it will start running itself at 26, probably during the day when the heat increases, when the heat in the temperature increases, it will automatically switch down to the lesser temperature such as 22 degrees or 23 degrees and give more comfort to the humans. So now the Mercedes-Benz and all these particular things, Maris-Gorez and all these particular things, automobiles, they have already implemented AI in their cars, which costs around some 50 to 60 lakhs, which automatically, if the rain is coming, the wiper will switch on. Once the night is going on, the light is faded, the lights will be on. Once the light gets more darker, the light gets more faded, it becomes more darker, the lights will be more luminescent, very bright, and the AC will control itself. So many things. AI is going to be integral part of our life, sir. So with that introduction, let me go out, let me share the screen and let me go out to the present topic. You should not be deviated from that, but this is just to give you an idea of how the AI is impacting in the day-to-day life of us. So my dear friends, let me go to the share the screen and Chrome tab, window, entire screen I would like to have. So I'm going to select share. Yeah. So my dear friends, this is our PPT. I will start the slideshow. Yeah. So can you see this, my dear friends? Can you see the screen?
Yes, sir.
Yes or no? Please give me yes. Yeah, yeah.
Yes,
Please give me yes from. Because I don't want to be disconnected due to this networking issues and all that. So drones are also called as UAV, that is nothing but unmanned aerial vehicles. Okay. So they are controlled remotely by a pilot. And okay, what are the components required? These are the various components that we have. We'll go in depth with each of these particular things. Okay. So my dear friends, can you please tell me, why don't we have these drones and all this 10 years back? Why suddenly we have these things coming up? Can you tell me? Can you tell me? Why don't we have battery technology? Yeah, Superman, Ravi Kumar. Yeah, you have nailed it. Super, very good, beautiful. Very beautifully. Yeah, because how the world is transforming, transforming, okay, is that software and connectivity were limited. Super. Oh my God. Azar, you have got good knowledge and visionary zeal of this AI technology. Azar, very good. Software and technology, the storage systems, microcontrollers. Now we are having TB and GPUs and all that. And processing speed has rapidly increased. These particular things were not there earlier. Okay. Now let us come back to this. So I shall stop presenting again, come back for the presenting. Yeah, I will start again presenting because there are multiple screens are being displayed. Now I shall start again presenting here. We shall go ahead with the presentation now. Yeah, I was telling you, my dear friends, the basic thing is that, let me go back to the slide over here. I should go to this bigger one. Yeah. Can you see the full screen of my presentation? BLDC motor, propellers and all that? Yes or no?
Yes, sir. Yes, sir. Please, sir,
Okay.
continue.
Yes, yes. So why do we have this sudden rise of all these battery vehicles or electric vehicles and all that? Earlier, we did not have the battery technology, which is lithium, which can store, which can have a high density and which can store the energy for a longer period of time. So today, we are mostly the communication is being the different aspects of a drone are being used for various applications. And then we have this drone coming up for various applications. So now basically, if we are going to see, yeah. So these are all the various things that we have in this particular drone. Yeah, I will go for the slides. Oh, slideshow on this. Yeah. It has basically a frame, and this is a propeller. This is the propeller. Different types of this particular propeller are there, and this is the most established. This four. You see the four. There is hexagonal, pentagonal. Okay, different types. Three propellers and all these particular things are there. But this is the most effectively used propeller that we are having in all our drones today. Okay. We have the BLDC motor here. Okay. And these are the propellers. Okay. Why do we have to have the propeller? There is a motor inside. There is a motor inside. And we have a propeller. These are the propellers actually. So we have the motor and this is the propeller. Why do we have to have the propeller? The basic important thing that we should have the propeller is to create a difference here. You see, my dear friends, create a difference in air pressure between the top and bottom of the propeller. So if you are going to see this slide, can you see this slide? Forces acting on aeroplane, yes or no? Hello?
Yes, sir.
Yeah. Just tell me yes, because I think I am connected. Okay. This is completely, the drone is operating on these principles. We have two important things that are happening here. One is the weight. Weight is acting, gravity is acting. For the aerodynamics of the particular plane, the weight is acting. Another one is the drag. Okay. These two things are there. So if the plane wants to be lifted, then at any circumstances, if I am, Sir Abhimanyu sir, if I am disconnected, please call me immediately so that I will get myself reconnected due to some issues over here, network problems and all that. So you have two things here. One is the drag, another one is the weight. That is nothing but the gravity. So we need to have this lift. We need to have the lift as well as the thrust to make it go into the forward direction. That is, the thrust is important. And for an aeroplane to be lifted into the air, it has to become less weight. It has to generate less weight than the gravity so that it can go into the air. Those are the important things that we require. So there are so many things. If you are going to see for the aeroplane, see, my dear friends, this is the aileron. Here you have in the wings. You could have observed somebody going on the plane. Just before the window seat, you have two things that are known as the ailerons, and there is a back. Also, there is a thing that is known as rudder. Okay, this ailerons and rudder, they are going to control this lift, my dear friends. This lift. So, what is going to happen initially? This flaps are going to become down. These flaps are going to become down. So that what is going to happen? There is a low pressure that is created. Okay, there is a low pressure that is created as compared to the high pressure. So the intensity, the requirement of downing these flaps is to create a low pressure such that the flight gets an appropriate lift. You might think, sir, how, sir, small flaps on that wing can generate that much pressure, sir? That can make some difference in the pressure. That is how aerodynamics works. And you can see the first Wright brothers engine also has the same sort of this curvature profile, some sort of a conical profile or something, epicycloidic profile or something, where there is a intentionally being done, the design is being done to create a pressure difference between the top side and bottom side. Okay, top side and bottom side. So when this is being created, there is a flap that is being taken up. So, and aileron also to make the movement left side or right side, these same things are going to be moved in that way. Okay, so aileron is there, rudder is there. Now come to our drone. Now what is happening? There is a weight acting on this drone. These are the four motors and these are the propellers. Now what is happening? Now the propeller should rotate in that much speed, with that much speed, they should counteract the gravity and the weight it is acting on this particular drone such that there should be an ample thrust. The green arrows are the thrust and this is the weight. The red weight is very big, you see, my dear friends, and the thrust 4 motors are developing so much thrust in such a way that what is happening when the thrust is developing, the drone is going topwards, upwards. Okay, similarly, my dear friends, see, yeah. So similarly, so what is happening here? If the drone is going to go forward, if the drone is going to go forward, am I connected, my dear friends? Yes or no? Hello? Hello? Hello?
Yes, sir.
Yes, sir.
Okay, okay. Please be responsive immediately so that we will not waste time. There are so many things that we need to discuss over here. So if the drone wants to go forward, obviously the speed of the, whenever you touch, I will also show you the drone we have with me. Whenever you have the radio transmitter where there is some small joystick is there, you are touching the forward motion, you are putting the lever in the forward direction, you are making the joystick move in the forward direction. The joystick, what it will do, it will make this electronic speed controller ESC in such a way that the forward rollers, the forward motors will decrease the speed, the backward motors will increase the speed. Then obviously it will go in the forward direction. If it wants to go in the backward direction, similarly, what is going to happen? What is going to happen? The speed of the forward motors are going to be increased immensely when you are pressing the in the radio frequency transmitter or the remote. I call it as a remote. You are pressing the same joystick backward direction towards you. What is happening? The speed of this these two motors is going to immensely decrease, whereas the forward motors, the speed is going to be immensely increased such that it comes in the back direction. Similarly, what happens is that if you want to move it in a side direction, obviously in the side direction also, instead of this forward and reverse direction, the side motor speed is decreased, the other side motor speed is increased, it goes in the specific direction. If you want to make a roll or rotation of the drone, then the diagonal motors come into the picture so that it is going to rotate. It is going to rotate. So this is the basic aerodynamics that we have in this particular drones. Okay. So now, my dear friends, what I am asking you is that have you understood? What I have been telling until now? If so, just raise your hand. If you are properly following me, you say raise your hand. Thank you, Azhar. Please raise your hand if you are following what I am saying up to now. Thank you, Ritu. Ashok Kumar, thank you. They are raising 4 times, 5 times, Naveen sir. Thank you very much. Yeah, that means yes, we are. Thank you, Sivamma garu. So that means we are in right track. We are in right track, and Azhar again, thank you very much. So we are in right track, and we had been following the concept very thoroughly. And until now, we have not gone into the actual topic. To remind you, we are just discussing the Somnath sir. Thank you very much. So we are not discussing the actual concept. We are only discussing to have a basic idea of the drone. Okay, today I'll be giving the overall picture of this IoT, cloud, and AI ML in the drones. Tomorrow, I myself with my students who are working on this machine learning, object detection, drone data sets, and all these things, we will go deep into this matter. Tomorrow, we have a session from 6 to 7:30. Again, I will be discussing along with my students the application of today's discussion, whatever we have, we will discuss tomorrow. Okay, now again, let us go back to our this thing. So what I will be precisely doing today is that I will discuss with you how a machine learning model can be developed. How a machine learning model can be developed by taking a simple example of temperature control. Whatever I said, AI in the AC, I want to control the fan speed. I don't want to use the regulator. I want to put a relay and a microcontroller inside my switch box, which connects the fan. And the fan, depending upon the outside temperature, I'll be connecting a DHT11 sensor. Depending upon the temperature of IoT device, the fan will automatically rotate in the specific speed only. If it is very chill outside, it will rotate in 1 or 2 only. If it is very hot, it will rotate in for speed number 5. Okay, like that, I have developed that project. I will also show you the YouTube video of that. Then I will come back to drone. What is the impact of that drone for our case study? The case study is today's session is AI in the flood detection system. How if the drone is detecting human intervention with the help of a image detection technology or sensor technology by means of a thermal sensor, it detects there is a presence of human in the flood or any calamity or any fire accident or any typical situation. It is going to detect that's and communicate with this motor controller, where I said the fan is controlled. You see, I have said one example. That example I have taken from an YouTube video of a Edge AI implementation in a donut manufacturing company in US, in California. They have implemented this, where the fryer is supposed to maintain its temperature for the optimal burning of the donut. If it's burn out, then it's not useful. So the exhaust fan should be on if the temperature is exceeding. So they have implemented this machine learning model. Same model I have developed. I will also show you the YouTube video in a short time from now. So the same technology I have implemented in the drones. It can be implemented. I have not implemented. That can be taken also as a research problem for you. It can be implemented where the speeds can be automatically controlled and the drone moves to the specific direction. So why do we have to have this AI in the drone technology? So my intention is that once it detects the object, a person in calamity, it has a life jacket with it. The drone has a life jacket with it. So it will process the image and it will detect at exactly what location is the person is there. So we are operating autonomously. The intention of this AI in the drones is that we are nowhere, the operator is nowhere in that particular thing, but the drone has immense battery capacity. That is the one of the most limitation factor or deciding factor for the operation of the drone. The drone can selflessly operate for about half an hour to 1 hour with the battery conditions. That is one requirement that we have. And it should have a high-end GPU, graphic processing unit, because there are data sets that are involved with the with this image detection technology, image detection system. I should not say it as technology. It should process the images and it should process the data sets concerned with respect to the image, take appropriate decision, and the speed of the total thing comes here. What I am saying, why I'm saying this project and all these particular things, the beauty of these things, whatever my project comes with the picture here, automatically the front motors and the back motors control their speeds automatically, and even the left motors as well as right motors as well as the diagonal motors. The controller is built in such a way that it processes these image detection techniques, it processes and gives appropriate commands from the microcontroller to the motors such that the speeds can be varied and it reaches to the the person who is carried away by the flood within no time and leaves the life jacket to that particular person and saves his life. So here, my dear friends, we have limitations. Why are also we going to the AI? Means computer science people can correlate that more because we are moving away from the logic-based programming. So depending upon the situation, we cannot have a new controller or program it at that particular point of time or precisely locate the coordinates and all these particular things, which are the limitations in the programming. We are giving a totally trained model to the system, to the system. There, it is taking its own decision according to the situation and moving to the point and releasing the life jacket within no time, such that the human life is saved. That is the intention of this particular project. Now let us go back to this project and let us see how we have done this. I will show you. So yeah. Entire screen. I'll get back to this. Yeah. Yes, slideshow from current slide. Yeah. Can you see these propellers, my dear friends? Yes or no? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. Propellers. There is a motor, and yeah, I will show you the drone last. So these are also some of the propellers. This is the electronic speed controller, which controls the speed of each motor. And this is the other types of electronic speed controller. This is the flight controller. Okay. And everything microcontroller is a computer, I can tell you, because I am an IoT specialist. Every microcontroller is of different type. Okay. It has a specific PCB layout, and it has some different transistors, diodes, and ICs are embedded into it. And then it is used for a specific purpose. And IoT, we have embedded system, which is nothing but this microcontroller is flight control is different from whatever the microcontroller that is being used in a washing machine, and the microcontroller that is used in the hair drying machine, and the microcontroller that is used in an ATM machine. Each has a specific purpose. Okay. So this is a flight controller, and these are all the different types of flight controllers we have. And this is the another type of controller. And this is a Pixhawk controller. Okay. Apart from that, the drone has also some different types of sensors, gyrating sensors, and all these particular things, thermal sensors, and GPS, geographic positioning system, all these things. But as you go on increasing these compatibilities, for example, we have, this is the radio transmitter or remote that we are having. This is the most important, my dear friend. This is the battery with which the drone is actually flying. Okay. So the battery capacity has very drastically improved nowadays. Okay. So this is the camera, which is the most important component in the entire drone. Okay, but you have to understand that there is a turbulence. There is a turbulence when the drone flies. In the drone that I generally use for training for 3,000 rupees and all that, we don't have that gyrating sensors and all these particular things. It cannot control the turbulence. We need to balance the drone for very frequently, such that it gets not carried away by the wind and all these particular things. But 1 lakh drones, 60,000 to 1 lakh and all, they have the advanced this gyroscopic stabilizers and all these particular things, advanced GPS and all that. You can even press, the drone is going away or carried away or drifted, you can press home button. Again, depending upon the GPS location, it will automatically come to you and automatically get landed also. So the functionality, the compatibility, the capabilities improve with the cost that is associated with this drone, my dear friends. And there is also this gimbal that is coming into the picture, which is called as a mechanical stabilizer, which can counter this turbulence and all these particular things. So the 3 lakh drone that you are going to use in most of the, but as far as my knowledge, we are now implementing most of these things in the delicate situations, thrust situations such as firefighting and all these particular things, flood and all these particular things. We are expanding the domain of this drone technology to various applications. But earlier, probably around 5 years back, we can think that this is the technology that we can see in the most of the marriages where it is being taken as a privilege to have a aerial drone view of the bride, groom, and the bride and the relatives and all these particular things. So that uses, that was a 3 lakh drone. When I asked him some probably around 5 years back in a marriage, which has got this gimbal. Okay. So this onboard computer is also there. So let us now come back to this. Yeah, this we have seen already, how the drone moves. These are the some of the things that we need to have the drone basic idea about this. So there is a lift. To get airborne, you must create a lift. Okay, and also there should be a direction control. So accelerometer is one of the important thing. Sensor part I am talking. Gyroscope also is important. So remote control and Wi-Fi should be there. Inbuilt Wi-Fi should be there for that one. To communicate from the radio transmitter, it has to receive this. It has to receive the commands. Then the microcontroller will be activated. And these are the different types. So these are the 10 golden rules to fly. There should not, you should not fly if it's more than some. There is a 150 lbs, 151 lbs, 7 kg, above 7 kg, you cannot fly without permission. Okay, there is a limitation in that. For this 3000 and all, you can fly. But my dear friends, you should take very much care that you should not fly in the busy areas, some ground where there is no human presence. For your training, you can use that, but be cautious while getting yourself also trained, because if the drone also get crashes in some instances, you might lose that 3000 instantly. Okay. So these are some of the things that you need to take care. This is the drone uses. Particularly, the consumer is using only 17% now, and the military is using 70%, and commercial is 13%. This total concept has been developed from embedded system, which is the combination of hardware and software. It should have the embedded hardware, real-time operating system, RTOs, device drivers, and it should have the communication stacks. It should have the embedded application. Okay, these are the various applications of the IoT. This is the global AI drone technology market, which has been increasing. It is estimated that it will be around 206.9 US dollar billion dollar market in the 2033. So this is the slide for computer vision. Computer vision is mostly used in the drones for the surveillance, for sensing and inspection. In the civil, we are using for the structural monitoring, that is called as structural monitoring. And in the land, optimal area detection, landing, package delivery, and all these particular things for surveillance and tracking. Whatever I said, the flood monitoring, flood detection, human detection in the flood, and all this for search and rescue. This is the topic that I had been discussing. So this is the basic idea is to use the thermal sensors which can detect heat, and then with the help of the processing capabilities and all that, it can take up the appropriate location and leave the life jacket over there. So this is the, how does the AI work in the drone technology? Yes. One thing is autonomous navigation and path planning. Another one is the swarm intelligence. Swarm intelligence is that simultaneously you think some 5 or 10 drones are flying in the same area. Then it should not clash itself. That is the known as the swarm intelligence. They should work in conjunction. They should work as a team and deliver the purpose. What is the purpose that is being meant to deliver? Okay, that is known as the swarm intelligence. The other one is the perception and smart sensor fusion. The other one is the edge computing and real-time processing. I'll come back to that. Of course, we have computer vision and object detection, decision making and control, machine learning and model training. So machine learning model we are going to see shortly. So my dear friends, now have you understood up to now? If you have understood, please give me a hi. Please give me a hi if you have understood what we have discussed until now. Before going for the learning the machine learning model. Thank you, Mira. Aarti, thank you. Thank you very much. So you are enjoying the session, Azhar, thank you. Nupur, thank you. Yeah. Dr. Sweta Agarwal, hi. Yeah. Thank you very much. Yeah. So that means to say that you are enjoying the session. We are in track. We both are connected, and my frequency is also matching your frequency, such that you are learning something new, advanced, and interactive, and definitely will help you in your career a lot. Okay, let me show you the drone now. Yeah, this we have the 4 windows. Yeah, can you see this drone, my dear friends? Can you see it? Yes or no?
Yes, sir.
This is the motor. There is a motor here. This is the propeller. This is the propeller. Okay, and this is the camera. This is the camera. We have to manually, because this is only a 3000 camera. Explaining so fantabulously. Go on, sir. Azhar, thank you very much. Yeah. Fantastic and fantabulously. Oh, beautiful. Super. We'll have more sessions with you, Azhar, in the coming days. Okay. So, because I'm a trainer, I'm an entrepreneur, I'm a scientist, I'm a teacher, I'm a professor. I have gone through all the trades, so I know how to get things to you. So that is the advantage with me. Okay, then. So this is we don't have a gimbal here. See, my dear friends, this is only a demo drone. My actual training drone is something different. It's different. This is the first drone, my friends, I purchased some 3 years back, and there is a clear instruction on this manual. Please don't fly it on top of the apartments and all that. Okay, so I just switched on the drone, and I don't know how to control. Very pretty thing, you know. I don't have the basic control. Moreover, I am flying on the 5th floor of an apartment. I should fly it in the down, go to the ground or somewhere. I should fly it. I started it. I don't know, my dear friends. It had slowly lifted into the air. It got carried away by the wind. Boom! It fell down to the ground, 5 floors down. Motor gone. That's all. I tried to replace the motor, do something and or something, but it was never that. So I tried to. Now I'm using it as a demo drone. Okay. So there is a microcontroller inside. Okay, I could not open it, and this. If there is a gimbal, this camera is going to be adjusted automatically. And there is no problem with the turbulence and all that. And these 2 batteries I am using for my drone, because it has only 15 minutes capacity. I am using both the batteries for my training drone. So this is the provision where we put the battery. So this is it, my friends. And we have an antenna, my dear friends, over here. This is I can tell you, this is the controller where we have this joystick, this one, to move sides and to move forward and bottom, to counter the turbulence, to go to the height switches for the go to the heights, come down, home, and all these buttons, switch on and all this. So this is the basic idea about the drone that I would like to give you. Now, let us go to the machine learning model. So by the understanding this model, anybody of you can develop a machine learning model at your convenience with simple laptop. No need to have advanced graphic processing units and Ryzen microprocessor and all that, high GPUs, dedicated GPUs and all that. you can use some softwares which I will tell you short time from now. Develop a simple machine learning model. I will explain with my project. Then I will correlate that to the our present topic of how we can control the speed in the flood detection system, speed of the motors in the flood detection system. So all good. Until now, we have been going good. Things are very interesting for you. The things are very informative for you. I'm very happy that you are learning something out of this particular session. And you can put on Amazon. I think the cost also has come down for about 2,000 Indian rupees, INR. The cost of the drone, you can get it in Amazon. And it has also a beautiful camera. The camera is astonishing. The camera is very good. And whenever you go for the picnic, you are a content maker, you are doing some YouTube videos and all that, you can take those videos. You can start even the training sessions as a part-time job on these drones for the school children. You can make some money out of that. There are a lot of possibilities with the training that you had today. There are a lot of YouTube videos on these particular things. And of course, there is a chat GPT, your friend is there who can help you out in various ways. We use chat GPT in my classes, in my trainings and everything. I'm a friend of chat GPT, a close friend of chat GPT. I'm proud to say that to you. So the generative AI is going to remove the barriers of these engineering branches, mechanical, electronics, and all, and give us all a beautiful strength of this understanding the hardware and developing codes. And the code, I believe that it is nothing but the life. And drone cannot fly if it does not have the code in that microcontroller. And we cannot input a machine learning model without a code. For everything, code is the life. Code is the prawn. Prawn of that embedded system is the code. That is why, my dear friends, you like it or not, we should always develop a flavor for the computer programming. Now you don't have to develop. You have generative AI's Perplexity, ChatGPT, but you should have the foundational knowledge of these hardware components and the complete idea of what is the project that you are going to develop. And then give the everything in the form of the prompt to the ChatGPT. And then beautifully, my dear friends, it gives you the roadmap, it gives the coding, it gives the required hardware. And at any point of time, until you get your project is successful, my dear friends, the potential and the scope, the domain, the zenith of these generative AIs is truly astonishing, my dear friends. Yes, of course, there are trained models, AI models available for use in the OpenCV. You have an YOLO and all these particular things. There are trained models that are there, but for a specific application, you want to develop a model on your own. Obviously, my dear friends, this will give you a beautiful advantage. Somebody like, I can say, a person having some 10 to 15 years of knowledge on these technologies, that way it can give you the suggestion and make you train from the bottom, but from the beginner level stage. Okay, now let us go back to our this thing, because I think we have time from 7:30 to 9. We should move somewhat fast. We have half an hour more, and we'll also have some doubt session for 10 minutes. So we need, I think we have another 20 minutes with us. It's already 8:30, my dear friends. So let us now go back to the sharing aspect of this. Yes. Yeah. So here, how I developed this machine learning model. This was done by me on my own with the without the help of any student. I already told you where I got the idea. I've taken a DHT11 sensor and a 5 volts DC fan with a ESP32 microcontroller. So I've developed this data set So there is a formula for this data set, which I have again got it from ChatGPT. So with respect to the temperature in my staff room is only 25 degrees. So I started from 20 degrees. For up to 20 to 22, I put the fan speed as 1. From 23 to 25 to 26 to 28, 3, 29 to 31, 4, and the remaining is 4. Only 4 fan speeds I have taken, my dear friends. And I will go from here. Yeah. So what should we try to do for developing this model, trained model? First thing is that you develop the data set. Data set is nothing but you develop it in Excel, convert it, export it as a CSV file. Your data set is ready. Upload it to the Google Colab, okay, and then ask it to process it. Then it will give the thing in terms of weights and float. In terms of weights and float. Now I want to come back to you. I'll stop sharing. Yes. Can you tell me what is weights and bias in a machine learning model? Can you tell me, anyone? Can you can unmute and tell me what is the weights and bias? Any computer science person over here in a machine learning model? Am I there? Am I connected? Yes or no? Hello.
Yes, sir. Yes,
Yes,
sir.
sir.
Yes. Yes. Can you tell me what is weights and bias? Anyone? An idea?
As far as the bias is concerned, sir, it is the basic input-output system device. That is the time taken by the system whenever it is turned off or the switch is turned off, I guess.
Okay. What could be
It
the
also
weight?
defines the clock speed.
What is that?
It defines the clock speed, that is the time taken by the system or an operating system.
Okay. Okay. Good. So, in the preview of a data set, what I mean to say with respect to the weights and bias is that how the data, if suppose I am taking from the DHT11 sensor, I have taken only temperature. I am taking two things. I have taken two things. I am taking a temperature, I am taking the humidity. So weights will be given by the Google Colab. The output that the Colab after processing the data set will give weights, a separate factor for the weight of the temperature, a separate factor for the weight of the humidity. So that is going to be added with the bias. Bias is the common. Suppose you are making noodles. My dear friends. The basic noodle manufacturing is the same. That is, you put hot water, you put the noodles into it, you burn it, you put some salt and all these particular things. Okay. So weights is how you want that to be, how you want your noodles. You want to make it spicy, you want to make it normal, you want to make it less spicy. So this, what is the influence? That is known as the weight. So all can write your queries here. Okay, sir. You can do the message over there. So what we can do, we can have the data set. The data set will be processed by the Google Colab. It is just on the browser. You open Google Colab, it is on the browser. It gives you 1 GPU processing and it runs neural network for your data set. So, and it gives you the weight. Weight in the sense that how is the spice, how is the mirch you are putting. I'm occasionally I'm getting the Hindi also because I'm basically from Andhra Pradesh, Tirupati. I'm working in the Hindi speaking area. Sometimes the Hindi also will be mixing with my English. How you are putting means I'm telling, I'm getting out of my mouth how you are darling. Dal do bolta hai Hindi mein. How you are darling, that is also a good thing, a funny aspect of that. How you are putting the mirch, salt, you want to make it more salty. That is the weight. So how is the influence of those parameters on the data set? That is given by the weights. The bias is going to be always remain the same. That is the basic thing, is the bias. Okay, according to my knowledge, how the machine learning model can be developed is with the help of the weights and bias. So once I'm again going back, my dear friends. Okay, so from that, what I am having, I got the weights and bias. This is the weights and this is the bias. Okay, weights into temperature, whatever is the temperature, weight factor. I can say it as a weight factor. It will be some 0.83 or something. If I am having humidity also, it will be having less influence on that. It will be having some 0.11 or something like that, lesser factor than temperature. Both of these things are going to be multiplied. Then it is going to be added with the bias. Finally, you are going to get the fan speed. This is given by the Google Colab. Next, I am giving the same weights and bias to the ChatGPT in order for me to develop the ESP code for that one. So here, the weight is 0.5. That is 0.5 is with respect to only temperature. I am taking only temperature. If there are two parameters, I will have W1 and W2, which are going to be multiplied with each other with the temperature, weight 1 plus weight 1 into temperature plus weight 2 into temperature plus the bias. Okay, the bias values, these values are going to be generated with the Google Colab. This entire process we are trying to do to train the model. We are mimicking the human intelligence in the form of artificial intelligence by a machine learning model. This is what we are trying to do, to generate these weights and bias in the sense that how the mind thinks with the help of neural networks. The same thing we are developing with these factors, that is weights and bias. The same thing we are trying to give it to the ChatGPT. It develops me the code for this ESP32. Then, my dear friends, I got the entire code. I am going to upload this code. Okay. And automatically you see the speeds 1, 4, 64, 255. These are the different speeds at which the fan operates at speed number 1, speed number 2, speed number 3, and full speed 255 RPM. Okay. So this is how it is developing that. And yeah, I will show you now the YouTube video with respect to that. I'm still in sharing. You can go to the, I will close this PPT and I will go for this YouTube video. Can you see this print 3D technologies? Can you see YouTube video? Yes
sir,
or no?
sir. Yes, sir.
Yeah, please go to my channel afterwards. You go to my channel. This is my channel, Print 3D Technologies. You open that. And here you have this shorts. You have the shorts, ML-based IoT temperature control. This is the project. This is the DHT sensor. This is the ESP controller. ESP controller is more loaded with the microcontroller, the program. And you have an online representation in the serial monitor. What is the temperature and humidity, and the fan is rotating here. It was very intense hot day. The fan is rotating at top speed. It's connected with the battery pack. This is the practically applicable machine learning model that we have tested. Simple project. In this, I have combined IoT. I have not combined the cloud, AIML. For the one particular application, I want to develop the temperature controlled fan, AI model. Okay? Okay. So I will stop this over here. Now I will get back to this. I will get back to this. Yeah, just a minute. Yeah. Yeah. Are you able to see the steps of implementing AI ML in drones? Yes.
Yes, sir.
Yes, sir. Yes, sir.
Just a minute. Steps of implementing. Just wait. Yeah. On current slide. Yes. So, how is this ML project that I have done for the fan temperature control is useful in the rescue and the threat system? How can the AI trained model can be integrated into that? I will discuss. So here we have, okay, my data set is very limited. It has a very limited parameters, does not require that much processing. It can be incorporated into ASP32 system. But what we are going to discuss, what you are going to do it, if you are interested, that requires high-end processing. Okay, what is the YOLO detection system or these GPUs? That will be basically different because you will be having the data processing, image processing, which requires higher storage capacities, higher processing speeds, and all these particular things. So, what do we have? What are the steps we have here? Data collection, image processing, object detection, classification, and evaluation and analysis. So this is how this you have to note down that the model can be trained with the help of a CSV file. We call it as a structured data, or the model also can be trained with the help of these images, which we call it as a non-structured data. So with the help of this also, we are going to train the model how to detect the human detection, human presence. Okay, by the image detection system, by the YOLO and all that, we are identifying that particular person. Okay, next, even in the case of fire, there is a fire in the apartment, there is a human presence. It has to detect that particular person. Okay, so this is the route map of entire thing of the autonomous drowning rescue system. We have the sensor fusion and localization. We have the onboard AI and companion computer. We are using this is the practical model that has been used in some US based project or something. I have not done that to your precise information. And this is using NVIDIA Jetson, which is having higher processing and all that. Am I connected? Hello? Hello?
Yes, we are connected.
Yes, sir.
Yes, sir.
Yeah. Yes. There was some music, sudden music. Okay. So we have a flight controller. We have the motor controller. We'll come back to that later. So there is a sensor fusion. There is an thermal. Is also an optional in addition to the image detection system. So what we are trying to do, we are using the main thing here. It costs around $300 to $400, my dear friends. The processor itself costs around some 15 to 20,000. So this is very costly because it has to process this images. Images processing takes a huge amount of data, and the processing speed and all that is counted. So here the final, our part, where is our machine learning model, comes into the motor control. So to precisely go to the particular person who is getting drowned, the motor should be automatically control the speed so that it goes to the specific locations. This is where there is a flight controller which gives commands to this motors, and it is going to the required location. Okay, so that is how this project can be implemented. I have not done it. You can take it as a PhD project or MTech project. You can go ahead. I have given you all the basics of this one. So, and the controller gives the appropriate commands to go forward, side, in the same way which we have seen in the earlier slides, how to control the sides of the motor. So this is my training institute, and you can contact me. Just a minute. You can contact me at this number. You can take a screenshot of this 988542583. Anytime I will be available. I can also come to your institute and give the offline sessions in IoT, embedded systems, cloud computing, AI, ML, and all these particular aspects. So that is it from my side, my dear friends. I hope you have enjoyed this session. We have covered many topics in a short span with the help of you. And you are really good audience. You are very intellectual. And I also thank this platform where we people of like-minded people who are technically savvy, who want to learn something new, who want to contribute to the society, who want to contribute to develop ourselves. I've extraordinarily been doing a lot of things here. So, my dear friends, that's it from me. I'll get back to you. So, how was the session? You can give some feedback before going to the doubts. Did you like this? Is it informative? Did you get anything out of this? Please tell me. And please watch my YouTube channel. It's too good. Thank you. Paul, thank you very much.
All of you, I have shared
And,
this YouTube blog channel. If any doubt, you
yes,
can
sir. Yes, sir.
any feedback, you can share with sir.
Yes, sir. Yeah, yeah.
We have another session in tomorrow, 6 p.m. Sir will
6 to 7.
6
Yes,
to
sir.
7:30. Sir will be there. Right now, if you have any doubt, any queries, if you want to interact with sir,
Thank
please.
you. This is absolutely knowledgeable. Thank you very much. Your
Ritibeni,
session is very good.
Sarojini, some of the
Yes.
contestants are given their raise your hand.
Yes. Sir, if possible, ask them to unmute also and ask the question, sir.
Yes, you
I'm
can,
very
all of you can unmute your channel and you can directly ask.
And please follow my channel, share, like, subscribe, because there is a lot of IoT projects, drone projects, everything is there in that. From basics with code, everything.
Thank you, sir. Thank you for the knowledgeable data, all the data given by you, sir. I have one question to ask, sir. Is it yeah, you have said about the yellow AI model? Sir, is it able to process all the data or anything else by the drone itself, sir?
Yeah. That's what I want to specifically make it clear, sir. My model, machine learning model, is only for the fan control, sir. Fan control in a specific room where the data set is limited, sir. Data set is limited. It is structured data. It is in CSV file actually. So I am only giving the audience a flavor of what is the machine learning, how a model can be developed, how a model can be trained, how a model can be incorporated into the microcontroller, so that appropriately they get the desired output. Because earlier, for controlling the fan speed, I used to give the microcontroller programming. If the temperature is this much, control statement, run the fan at 64 RPM. If the temperature is this much, now I am giving individual, I am giving the trained model, sir, because of the weights and bias, it is taking its own inferences. The model is taking its own inferences. Then it is taking its own decision, sir. You are not doing any programming now. And the trained model will be helpful for any appropriate adverse situation, upcoming situation, because it's already trained. It will take an appropriate decision and it will help you out of the situation, sir. It will give you the proper solution out of that. So, sir, again, I'm saying the NVIDIA Jetson, I have said, sir, I'm telling you, that is an advanced processor, sir, that is required for the image processing. Tomorrow, my students will discuss the image detection, YOLO, and CSV, OpenCV, and all these particular things. Probably you can have a complete idea of what I have been discussing in the tomorrow's session, sir. That is the part 2, sir. Without part 2, I think the part 1 will not be complete. So this is only, I have started, sir. I have made a route map. I have just started your journey in this particular new and emerging area, sir. Any more questions, sir? Please unmute yourself and
Anyone is there if you want to interact with sir?
Very good evening, sir. This is Azhar again, sir. I'm sorry.
sir, where are you
I
from?
hope I'm from Kashmir, basically, sir.
Oh, very good, very good. Please tell me.
Yeah. Thank you so much for the lovely session, sir. It was very informative for all of us. I had actually a generalized question about the security first. And after that, I wanted to know if you can assist us with the Manet, sir. How is there any possibility we can combine the Manet and Vanet itself?
Combine what?
It is Manet mobile ad hoc networks with the vehicular ad hoc networks.
Oh, no, I don't have that much idea on the Manet first. That was the, I have limited knowledge of these particular things. So basically, my idea is to float this technology because this machine learning, AI and concepts are very much new, and people are not able to give a proper basic idea about this. So I am only concentrating on floating these new technologies in the most simplest sense to the faculty, such that it can be transmitted and delivered and transferable to the upcoming generations. That is my intention. I don't have basic idea about the Manet. That is first thing that I would like to say. What is the other question you are asking, Azhar?
It was about the security, sir. We are
Security.
having
Yeah.
AI.
Security. Yeah. Security. Let me come to that particular point. Security. Whenever I say myself to the cloud, I use the Google Firebase. It is free online platform that is available, and it has a proper email authentication and all these particular things and all that. Your project is very much secure over there, but it is billable. It is under billing if it exceeds some specific storage limitations and more functionality you need to put in. Sending notifications and all this particular. It is a cloud software, Google Firebase. It has a API and web interaction and all these particular things. So it is secure. It is secure. Now the security issues, because most of these platforms, Google and all these particular things, with the linking of the integration of the API and all these particular things, the cloud is more secure. You don't have to worry about that. It is more secure. Yeah. Any more doubts, please? Please ask. Your doubts will give me a new lookout of extending these technologies.
Yes, I thought
Please.
they will be not asking for doubt. It is just an interaction. Anybody else?
Yes. Doubt also, you don't put it that way. It is an interaction. You can ask any easy interaction question also. Silly also. I will inform. I will talk because my duty is to clarify and provide knowledge on this. Please. Did you like my session? First of all, you tell me, any one of you. How are the
It's a
things that I have
definite-
dealt with?
Yes, sir,
Yes,
very
sir.
much.
Yes. Thank you.
If no doubt or no interaction, then we can conclude and giving the appreciation to sir. On behalf of all the participants and this Aiet Institute, I want to express our sincere gratitude to you, sir. Your contribution as a research person, I thought it is a very wonderful session, and everything,
sir.
everyone will be anticipated, and you have highly anticipated and proved the most this insightful part of this program. Your depth of this expertise, I thought it is a, all of you can know your presentation is truly, it is a fantastic one. Everyone will
Thank you,
be,
sir.
I've given what a feedback form. I thought everyone will be given a extremely valuable and practical session that is going on.
Thank you, sir. Thank you very much. Thank you very much, sir.
We will be waiting for you tomorrow, sir. What can you give? We all are waiting. And thank you once
Yes,
again for taking the time in a sort of busy schedule. And anytime I have called you, you just answer me. And thankful
Yes,
to
sir.
you, sir. Your knowledge
Yes, sir.
and your experience will be enriching the participant.
Yes, sir.
Thank you again, sir. We will meet again.
Thank you, my dear friends. Yes, Kavya Rasan, thank you. Thank you for your comment. My dear friends, it's very good to associate with you. And please get back to me, have my number. Please I will be available only on WhatsApp. Mostly I'll be traveling to different parts of India. And I have a close connection with Aryan. I have conducted number of offline sessions at Aryan when Sahu sir was there. Sahu sir is the instrumental person who had made this
Yes, sir.
possible, sir. I have to be very thankful to Sahu sir for giving me this opportunity. And please tell me, sir, Aryan is like my parent institute. Anytime you want any offline session, I will just pack up because
Yes, sir.
but it is only.
We are planning for next in 2-3 months. We are planning any workshop, some
Yes,
workshop,
sir. Yes, sir.
workshop or 3 days workshop. We will be definitely invite you.
Yes, sir. But the only constraint is that I cannot come by train. It takes 36 hours. You have to provide me ticket to and fro. That's the only constraint.
That one managed by the management, sir. Don't worry, sir. We are
Yes, sir. Yes, sir.
that
Yes,
much
sir.
we
Yeah,
can
yeah.
afford.
Yes, definitely, sir. My dear friends, thank you. Nice nice talking to you. Nice interacting with you. And my dear friends, I will look back to get associated with you in tomorrow's session. Tomorrow evening 6 o'clock we will come back. We will join. We'll have more things getting onto the ground tomorrow. Thank you very much. Bye bye for now. Good night. Enjoy.
Thank you.
Thank you, sir. Thank you so much, sir. It was so
Good night to all of you.
nice. Thank you.
Thank you all participants for having patience and giving your time. And all of your
Thank you, sir.
numbers
Thank you,
are
sir.
there. Thank you all participants. Again, we will meet tomorrow.
Thank you, sir.
Good night. Good night.
Good night, sir. Thank you, sir.
Good night, sir.
And మధ్య మధ్యలో గెలుస్తున్నాం